Right. See, continuity at a point. A function f is said to be continuous at a if f is defined in a neighborhood of a. F is defined in a neighborhood of a. So if I take x-axis and y-axis here, I want to check whether it is continuous or not at x is equal to a. So we can take some neighborhood and a neighborhood. This is neighborhood. For example, x is equal to 2. At x is equal to 2, I want to check the continuity of the function y is equal to f of x. So what we have to do, we can take some neighborhood, like neighborhood in the sense of 2 means almost 1.999 or 2.001. Okay, these are very near to 2. At this point, you have to check the limit values. Limit value. Substitute this values in the given function. Substitute this value also. Given function, both at both the values, the function, the value of the function will be coincide. Okay, then LHS equal to RHS. Then at the same time, see left hand, this is left neighborhood. Okay, left hand side, the limit value is given by limit extends to a minus f of x. This is called left hand limit. And right hand side, okay, limit extends to a plus f of x. If both will be equal to f of a, both will be equal to f of a, then we can say that f of x is continuous at the point x is equal to a. So left hand continuity exists and right hand continuity will be exist, and both will be equal also. Okay, already we have seen that f dash of f of a minus nothing but left hand continuity should be equal to f of a plus right hand continuity should be equal to f of a. Okay, then only we can say that the function is continuous at x is equal to a. This is directive formula. This is first formula I said, the second formula, this is second formula. We have done many problems. Okay, like see here, if you want to say the function is continuous in some interval, open interval. Okay, take here, I'm going to take the function like this. This is a function. I want to say this function is continuous in the interval. This is a and this is b. If I take open interval a to b, except endpoints, you can take any point which is belongs to open interval a comma b, which is continuous. Nothing but there is no break at all. If we draw the graph of the curve without lifting a pen from a to b, then we can say that it is continuous in interval a comma b. If I take closed interval a comma b means it is continuous at every point in the open interval a comma b, as well as at end points of the interval, nothing but a comma b also. Then we can say the function is continuous in closed interval a comma b. Open interval, closed interval, nothing but each and every point it is continuous. We can say that it is also continuous at closed interval a comma b. See, f is right hand continuous. So right hand continuity nothing but a and more than a in the interval. If I take 1 to 10, so the function is continuous at 1 as well as 1 plus nothing but right hand continuity of 1, 2, 3, 4, 5, 6, and the function is continuity at 10 as well as 10 minus. 10 minus means left hand continuity, left hand value like 9, 8 like that. So if it's left hand continuity at b, right hand continuity at a. So what is it mean by? So here the function is continuity at end points as well as between that end points. Okay, discontinuity is almost 5 to 6 types there will be there. Okay, that already we discussed that the discontinuity of first kind, discontinuity of second kind. And clearly I told you that f comma g are any two continuous function. F comma g are any two continuous function at x is equal to a. Then I clearly told you f plus g, f minus g, f into g, f by g, c into f. If you multiply any constant with the continuity function, even that is also a continuous. See, f is a continuous, c is a constant, cf also a continuous. Sum is continuous, difference is continuous, product is continuous, and division is also continuous. And this condition already explained. If and g are not continuous at x is equal to a, this may continuous. This may continuous. Okay, last time even I have given example also. Okay, right? For example, step x is not continuous, and minus step x also is not continuous. When we adding these two, step x and adding some, this is f, this is g. When we are adding these two, it will be a continuous. Some cases, okay. Because step x get cancelled, we are going to get a constant function 1. That time, okay. So like that, and go through that types of discontinuity of first kind. In first kind, there are two types of discontinuity as there. One is missing discontinuity, and the second one is isolated point of discontinuity. This clearly I explained here. What does that mean by missing point of discontinuity? Limit extends to a. F of x is existent, but f of a values does not exist. Limit values exist, f of a does not exist, nothing, but how can you check the continuity? No, it is not possible. F of a also exists, then we can equating these two. Limit exists and f of a also exists, then if both will be equal, then it is continuity at x is equal to a. But here itself, f of a does not exist. We cannot find it is not a continuous, it is called discontinuity. This is called missing point of discontinuity. And what is the mean by isolated point of discontinuity? Both will be existent. In missing point, f of a does not exist, but isolated point discontinuity, f of a is existed. Very simple, Amma. This is a discontinuity of first kind. Okay, discontinuity of first kind, which is related to first formula. First formula, limit extends to a, f of x is equal to f of a. And discontinuity of second kind, that is related to second formula. Left hand continuity should be equal to right hand continuity, should be equal to f of a or not. First kind belongs to first formula, second kind belongs to second formula. Okay, right, isolated, nothing but both will be exist here. Limit extends to a, f of x is exist, and f of a also exists, but both will be not equal. That's all. When both will be equal, it is continuous. Both will be not equal, not continuous. And coming to second kind, already we have seen. Second kind, it has three types: finite, infinite, and oscillatory. That I already explained you. That finite, nothing but yes. So here limit values. It may be LHS, it may be RHS. Okay, left hand continuity at x is equal to a should be right hand continuity also. Left hand continuity and right hand continuity must be finite. If we find limit extends to a minus, it will be having a finite value. Right hand continuity also having finite value. Okay, limit extends to a minus, limit extends to a plus, both will be existed. But both will be exist, but left hand continuity not equal to right hand continuity. See here. Not equal, nothing, but it is called finite discontinuity. Example they given clearly, can go through that. Okay. We have to find a minus x a plus. A minus nothing but 0 minus. 0 minus means 2 power you are going to get minus infinity. Minus 1 by 0 you will get a at 0 minus. When you take 0 plus, 2 power plus infinity you will get. So answers you are going to get different answers. 1 by 1 plus 2 power minus infinity, is for left-hand continuity, LHC value. RHC value is 1 by 1 plus 2 for infinity. See, minus infinity plus infinity, here we are going to get two different answers. Left-hand continuity should not equal right-hand continuity. So here it is not continuous, it is called finite discontinuity. Then second one is infinite. Any one of the limit, like either left-hand limit or right-hand limit, like left-hand continuity or right-hand continuity having infinity value, then any one of the value. So it is called a infinite discontinuity. See here, either you can take left-hand limit, left-hand continuity or right-hand continuity at 0. So your left-hand continuity, we are going to get cos x by minus 0. That is nothing but minus infinity. Right-hand continuity, we are going to get x 0 plus nothing but cos x by 0. That is plus infinity. So limits, left-hand continuity is infinity, right-hand continuity is infinity. Here minus infinity not equal to plus infinity. So it is clearly discontinuous. So oscillator means here some particular procedure is there to check this discontinuity, right? Okay, we can't say here like when x tends to 0, we are going to get a sign infinity. Yes or no? 1 by 0. Substitute x value 0 here. Sign of 1 by 0, sign infinity. What is sign infinity value? Is it equal to 0 or 1 by 2 or root 3 by 2 or 1 by root 2 or 1? Can anyone tell that? We don't know. Anyhow, we know that sin infinity is a finite value. Maximum is plus 1, minimum is minus 1. So it is the limit oscillate between the finite quantities. So sin infinity lies between minus 1 to plus 1. Oscillate between finite values, but we don't know what is the exact answer here. Okay, so this discontinuity is called oscillatory discontinuity, and this is also called jump discontinuity. Some different names are there. Okay, right. Next, some theorems are there, intermediate value theorems, and intermediate means exactly midpoint we are going to get. Like we draw that this is f of a, this is f of b. There exists a point c, that is f of c. So f of c corresponding y value is y naught they are taking. Nothing but between a and b, there exists f of c. That's all. Okay, if you take the interval, x-axis, y-axis, this is a and this is b. Between this interval, there exists a point c like this. Okay, and it is continuous at that point. Then this is called intermediate value theorem. Then single point discontinuity, single point continuity. If you take any graph of the curve, it is continuity at only one particular point. It is discontinuity other than like remaining all the points. It is continuous only at one point. Then it's called single point continuity. Example they given. You get here, it is continuous at x is equal to 0. Substitute 0 here, 0. Substitute 0 here, 0. 0 equal to 0. So at x is equal to 0, it is continuity. Other values, student, if I take a rational number like 1, we are going to get plus 1. Irrational number root 2 minus root 2. Okay, so is there both will be equal? No. A rational number should not equal to rational number. Other than that 0, when we substitute 0 alone, we are getting this. Right, students? Only at 0 alone, both will be equal. Here, at only 1 by 2 alone, substitute 1 by 2, 1 by 2. 1 minus 1 by 2, 1 by 2. LHS equal to RHS. Only at 1 by 2. Other than this, x is equal to 1 by 2, substitute any other values. LHC not equal to RHC. This is called single point discontinuity, right? Fine, students, right? Then let us go for the questions. I hope that everyone is understood. So it's not like that. Simply remember here how to find, then how to check the continuity. That is only important. When we can apply the first formula, when we can apply the second formula, that's enough. It's not required to remember, okay, this many discontinuity points, right? The questions are easy alone, right? But logical. Few questions are lengthy in that continuity also. First one, we need to simplify it easy. And the second one also, we need to simplify, so not required that. Okay, fine, students. Right. Exercise 2, class 1. The first question. What is the first question? F of x is equal to, yes students, e power x minus 1 whole to the power of 2n e power x only whole to the power of divided by sin power n x by a into log 1 plus x by a whole to the power of n, and any other function 16 power n. X not equal to 0 and x is equal to 0, right? In the question, if they give what is they ask here, the value of a, the value of a is what? So to whenever they asking any value, student, in any question, definitely they'll give it is a continuity, continuous. Clearly they give it is continuous. See here, student, this is f of a value. Like since here we can apply the second formula, like limit extends to a minus or a plus. A minus or a plus, the both the cases it will give same formula. Okay, ma. So otherwise first formula also. Like limit extends to 0, f of x is equal to f of 0. F of 0 value they already given 16 power n. F of 0 value they given 16 power n. You should not substitute 0 in place of n. 0 is belongs to x value. X is equal to 0. There is no x, it is n. Very simple. Find the limit extends to 0 is function value, right? Here, clearly observe here f of 0 value is 16 to the power of n. Now, what about the limit extends to 0, f of x, limit extends to 0. See, it is a, we can do very logically e power to x. When we substitute 0 directly, can you able to substitute 0 here directly? No, we cannot substitute, students. We cannot substitute 0. If you substitute 0 here, e power 0, 1, 1 minus 1, numerator will be 0 by sin 0 whole power n. So sin 0 is 0, 0 into anything is 0, 0 by 0, undefined. Here we are going to get undefined value. Undefined value. Is it clear? Okay, what shall I do here? There is a standard formula is there. Standard formula. What is that standard formula? Limit extends to 0 e power x minus 1 by x is equal to 1. Do you know this? Limit like extends to 0 e power x minus 1 by x always is equal to 1. But is there any x? There is no x at all, right? So what I want to do is e power x minus 1 whole to the power of 2n by x power 2n into x power 2n. Okay, I multiply and dividing with this. Next, what I want to do, I want to write sine power n into x by a. There is a formula again, whether you remember or not. There is a formula. What is that formula? Sine x by x is 1. Shall I write here x by a? I want to multiply and dividing with this. X by a whole to the power of n. Into, again, it is in the form of log 1 plus x by a, x by a whole power n. Okay. Here also same. What I want to do is uh, log 1 plus x by a whole to the power of n. By here also I want to take x by a whole to the power of n. I am multiplying and dividing with this. Shall I write it? This is whole to the power of 2n whole to the power of 2. See, x by a whole power n means x by a whole power n whole square. If I cancel this, no, I may cancel this. These two get cancelled. X power 2 and x power 2 n get cancelled. Again, we are going to get same value. Am I right? X by a whole power n whole square. These three will be cancelled. X power 2 and x power 2 n get cancelled. Finally, we are going to get above value. So, according to this, see, x tends to 0, we can write x by a also tends to 0. 0 by a, dividing with a on both sides. 0 by a means 0 alone. So, finally, what will happen here? X by a also tends to 0. Apply this here. Student, I am going to write standard form here. Otherwise, you can substitute directly here instead of wasting time. So, limit value is apply limit separately. Yours this is limit x by a tends to 0. Here it can be written as e power x minus 1 by x whole to the power of 2n. X power 2n. By here downside is this can be written as sine x by x by a whole to the power of n into 1 by, see, x by a whole power n whole square. Shall I write here x power 2n by a power 2n? Yes, we can write into 1 by, this is all are in denominator only, 1 by, see, a log of, shall I write this as 1 plus x by a whole to the power of n? Yes or no? I have written log 1 plus x by a whole power n is there, x by a whole power n is there. I written separately. Now, if we observe this, clearly here, this is 1 according to the formula. This is 1 according to the formula. This is also a 1. Since, what are the formulas we are having? Since limit extends to 0, e power x minus 1 by x, or limit extends to 0, sin x by x, or limit extends to 0, log 1 plus x by whole divided by x, it is always equal to 1. It is always equal to 1. 3 formulas I have written at one place. Okay. Is it clear, students? Right. See, with the help of this, right now, see, this is 1, clearly this is 1, this is 1, this is 1. What is the remaining value? And also anything will be cancelled here. Export to n get cancelled. What is the remaining value, students? Limit extends to 0. F of x value is, limit extends to x by a tends to 0. Yeah, remaining value 1 power 2n by sine here 1 power n into, see here 1 by x power 2n by a power 2n. Shall I take into numerator? We'll write this value. So no, this a power 2n take into numerator, so remaining here 1 by 4 power. So finally this is equal to a power 2n. A power 2n we got, this is so since it is continuous at x is equal to 0, so limit extends to 0. F of x is equal to f of 0. If this is a power 2n, f of 0 value is what? F of 0 value is 16 power n. What is a value, student? 16 power n can be written as 4 square whole power n. This is equal to 4 power 2n. Comparing on both sides, a value is clearly equal to 4. Is it clear? What is the answer finally? A value is, yes. Any doubts here? Only few questions are there like this. Actually, what is the procedure here? When we get 0 by 0, we can apply L'Hopital rule. Okay. L'Hopital rule, right? P is silent, S is silent, S is silent here. L'Hopital rule. So what is the mean by that? Here we have to differentiate numerator and denominator, and especially in continuity, the L'Hopital rule can play very important role. That is nothing but what? What does it mean by L'Hopital rule? Yes, students, anyone? So limit extends to a f of x by g of x. Two functions are there, numerator. This is equal to, we get any like undefined form. Undefined in the sense like if we are getting 0 by 0, if I substitute the limit, like if I after substituting the limit, what we are going to get? Substitute in place of xa, f of a by g of a. If we are getting in the form of 0 by 0, then we can apply the L'Hopital rule. What is the mean by that? Limit extends to a f of x by g of x. They differentiate numerator denominator with respect to x f dash of x by g dash of x. Even though this is also 0 by 0, again you can differentiate f double dash of x by g double dash of x until you are getting a defined value. 0 by 0 undefined. So on you can continue until you get a definite value. First fx by g of x directly 0 by 0. When I substitute limit, after derivative also if you get 0 by 0, again you can derivative. We'll get second derivative. Even it is also 0 by 0, you can differentiate again until you get a definite value. Okay, this is L'Hopital and it can play very important role, right? Right, next. The next question is that already we have seen that this is with the help of Leibniz rule. Leibniz rule. So generally, what are the functions they may give? X cos 1 by x. Already we have seen NCRT, I think so. In NCRT, they given the question x square sine 1 by x. X square sine 1 by x. So we checked that whether it is continuous or not. We checked it, right? So clearly we conclude that it is continuous at x is equal to 0. Because first sine 1 by x is lies between minus 1 to 1. Here also cos 1 by x, it is lies between minus 1 to 1. First sine 1 by x, whatever the value you can give, it is lies between minus 1 to 1. Now the question is, okay, in the question they given cos. You can take cos here. Cos. Then the question x power n is there. X power a. So minus x power a lesser than or equal to x power a cos 1 by x lesser than or equal to x power a. So here this is continuously, only here a must be greater than 0. Nothing but. So when the question in the form of like x into cos 1 by x or sin 1 by x or x square into cos 1 by x or sin 1 by x or x to the power of 1 by 2, 2 by 3, 3 by 4, whatever it is, but the power should be greater than 0. If it is lesser than 0, what will happen? If a value must be greater than 0, even it is should not equal to 0 also, greater than 0. So even it's not lesser than 0 also. If it is lesser than 0, what will happen? A value is lesser than 0, 1 by x power a will get. So cos 1 by x by. So if I substitute 0 here, something by 0 we are getting. Something by 0, undefined. So student, remember that this kind of question, you can write directly the answer. A must be greater than 0. Then only with help of Leibniz rule, this will be 0 we get, this will be 0 we get. So then middle value also limit becomes 0. Now apply limit extends to 0. What will happen here? Limit extends to 0. Minus 0 power a 0 plus 0 power a 0. So whenever left side the value, right side values are coincide, 0 is equal to 0. So middle value also must be 0. So 0 is a finite value, it is continuous at 0. Like that, here also to get it is continuous, this power alpha value must be greater than 0. It's actually direct property, right? Now third question is that the f of x value they given x into 1 plus a cos x minus b sin x by x cube. So when x is equal to 0, the value f of 0 value they given as 1. Okay, f of 0 is 1. But x not equal to 0 means either x is greater than 0 or x is lesser than 0. Okay. Left hand continuity or right hand continuity. X not equal to means remember x greater than 0 or x lesser than 0. Nothing but left hand continuity and right hand continuity. In both the cases they given only unit function. But is it exists at x is equal to 0? Substitute x is equal to 0 here in the function. Either we get any defined value. Yes, students. The function I'm taking x into 1 plus a cos x and is b sin x by x cube. Okay, at if I substitute here limit extends to 0 f of x, what is the value we are going to get, students? Direct substitute 0 here. 0 into anything 0. 0 into b 0. So finally numerator 0. Denominator also 0. 0 by 0 undefined value. What to do then? So in that case, I told you just now, I explained El Hospital rule. What is the El Hospital rule? When we get 0 by 0, we can differentiate numerator, denominator separately. Okay, so limit extends to 0 f of x. I want to differentiate numerator and denominator with respect to x. UV rule. Here we can apply the UV rule. X into what is u, what is v here? X is u, this 1 plus is v. So since we know that derivative of uv formula is uv dash plus u dash v, right? So x into 1 plus a cos x is minus a sin x. Okay. Plus 1 plus a cos x into x derivative is 1. Okay. Now I differentiated this first term. Minus b x is there. Minus b x means minus b alone. By x cube derivative is 3x square. Okay, now. Student, when I substitute again now 0, what is the required solution? Amma? Yes, anyone? Students, anyone can say? When I substitute after now, if I want to substitute here in place of x0, what about the numerator? What is the denominator? See, if I substitute 0 here, 0 or 1 or 0 plus 0 into anything 0, 1, 0 plus 1 plus a into cos 0 is 1 minus b is there by 3 into 0 square. When I substitute in place of x0, now what will happen here? 1 plus a minus b by 0. Something by 0. Something by 0 means, what about students? Anything by 0, again infinity. So remember that in continuity, limit should not be infinite. I told you very clearly, it should not be infinity. Limit value always finite, but here we are getting infinity. But when we can say it is again exist numerator also 0. If I take here 1 plus a minus b is equal to 0, nothing but we are going to get 0 by 0 form, 0 by 0. Again, see, second time after differentiating also we are going to get 0 by 0. For that, what to do? Again differentiate. Let us take this is equation 2 again differentiate. So limit extends to 0 f of x is clearly equal to limit. This is, let us take 1 plus a minus b, I am taking as 0. So which implies we can written as a minus b is equal to 1 minus 1. Sorry, this is equation some 3. Here we need to find the value of a comma b. Am I right? What is the question here? The value of a and b, right? Okay, fine. We got one equation. We need to find another equation. For that, again we can differentiate here. Here again UV formula. UV formula you can apply. Here differentiate directly. Here b derivative is 0. Okay. Here limit extends to 0. Okay, time is over. Just 4 minutes only. Minus a times of x into sine derivative cos x sine x into 1. 1 is derivative is 0. A into cos x is a into minus sine x minus 0. That's it. By 3x square is 6x. I differentiate in numerator, denominator. Now again you can substitute the x is equal to 0. That's all. Again we are going to get something by